Hi, hello, welcome back to our channel. Today we are going to discuss about our next day of the Rayoptics. Already I have completed part 1. Just you have to go through the what is a reflection and everything I have explained. But now our focus is on refractive index and refraction. First of all, what is the refractive index? We have to say about the speed of the light in different mediums with the help of the refractive index only. What is the formula for refractive index? This is the velocity of light in vacuum by velocity of light in medium. Simply we can write it, velocity of light in vacuum is the c and velocity of light in medium is the c by v. So we should write it mu equals to c by v. This is measured in meters per second. This is also measured in meters per second. So there is no unit for refractive index. Just it is saying that how much speed the light is having in different mediums, in vacuum or in free space. What is the velocity of light? We know that 3 into 10 to the power of 8 meters per second. Like that, when you are going in, when it is going into the water, that velocity is decreasing. So like that, everything, what is the speed of the light in different mediums, we can say with the help of the refractive index. Then after this, immediately we are going to discuss about refraction. What is the refraction? Don't confuse reflection and refraction. Reflection means the light rays comes back into the same medium, that is called the reflection. Like that, refraction, what happens? Same, this is the surface. It is separating two mediums. This is the medium 1 and this is medium 2 and this is normal to the surface. When light falls on the surface, you know that this is the incident ray and this is the angle of incidence. When light is traveling from rarer medium to the denser medium, then what happens? It is bending towards the normal. And the angle between normal and this refracted ray is called the angle of refraction. Mostly we are choosing either r dash or we are taking to represent this one. So here I is the angle of incidence. I is the angle of incidence and r is the angle of refraction. If you want to show some difference, r dash also you can say that. And what are the laws of the refraction? Here also incident ray, normal and refracted ray. All these three rays are in same plane. And next one is very important, that is based on the Snell's law. What Snell's explained? Suppose first medium refractive index is mu1. Second medium refractive index is mu2, and already you know that when the light is traveling from rarer to the denser medium, like air to water, it is bending towards the normal. Same thing reverse you should think. When the light is traveling from denser to rarer, then what happens? It is bending away from the normal. So anyway, what is the common definition for refraction? It is traveling from, the light ray is traveling from one medium to the another medium. It is bending. That is the refraction. Then second law is product of the refractive index and sine of the angle is constant. This is the constant. Based on this, you can say that here two mediums are there. First medium refractive index is the mu1. Here angle of incidence is sine I equals to, you can write it mu2. Second medium refractive index mu2 into sine refraction is the r. So this is also constant. From this we should write it mu2 by mu1 equals to sine I by sine r. Okay, this is called the Snell's law. This is called the Snell's law, and you can observe that mu2 by mu1 we should write it mu2 1 also. What is the meaning for this mu2 1? mu2 1 is the refractive index of second medium with respect to first medium. Suppose refractive index of second medium is the water, first medium is the air. So what we are saying here, mu2 1 means refractive index of water with respect to the air. Suppose you are taking the class, you can say that, you can write it mu g air. What is the meaning for this? You should write it mu g by mu a. This is the refractive index of glass. with respect to refractive index of air. And you should remember that refractive index of air or refractive index of free space equals to 1. So that is the refractive index, and practically they discovered already refractive index of water is the 4/3. Then refractive index of glass is the 3/2. At least you remember these three values. Refractive index of air is 1, refractive index of water is 4/3, then refractive index of glass is the 3/2 or 1.5. This is about the refractive index, this is about the refraction, and first law also you know that. Then this is the second law, this is the Snell's law, and here we got one more formula, that is the mu2 1 equals to mu2 by mu1 sin I by sin r. And here one more thing, suppose already you know that first medium is air. If the first medium is air, mu1 is how much in this case? Mu1 equals to 1. So simply we can write it mu2 equals to sin I by sin r also we can take it. So this is about the second law of refraction. Not only this one, refractive index is depends on which parameters. If the refractive index is more, what about the velocity, and what about the velocity of the light, and what about the wavelength of that one? Everything we should discuss now. Look, what is the basic formula for refractive index? Mu equals to velocity of light in free space by velocity of light in medium. And here from this what we are saying, mu is inversely proportional to velocity. More refractive index, less velocity. Less refractive index, more velocity. Just now I said refractive index of air is the 1. Refractive index of water is how much? 4/3 or 1.33. It is more than 1. So where we can observe more velocity of the light? In vacuum only, not in water. Whenever it is traveling through the water, then what happens? Its speed is little bit decreasing comparing with the air. So both are inversely proportional, means we should write this mu1 by mu2 equals to v2 by v1. Both are inversely proportional to each other. Not only this one, you can give the velocity, wavelength and refractive index. You know that velocity is directly proportional to lambda. From this, mu is inversely proportional to lambda. So mu1 by mu2 equals to, we can write it lambda 2 by lambda 1. You know that in that rainbow or generally colors are having the different lengths. Which color is having the more wavelength? Red is having the more wavelength, less refractive index. Why? Both are inversely proportional to each other. So like that we do one problem also. Find lambda 2. If mu1 equals to, they are mentioning in problem, that is the air, immediately we are taking 1. Then mu2 is the glass. Glass you should remember 3/2. Okay. Then lambda 1 is the 2 angstroms. 2 angstroms. Then how to find out the lambda 2? This is the lambda 1. So with the help of this we can find it, because mu1 is the 1 by 3/2 is equals to lambda 2. We should find out lambda 1 is the 2 angstroms. So after simplification, lambda 2 equals to, when it will reverse, 2/3 into 2, 4/3 angstroms. Like that you can calculate. Not only this one, velocity also we should find out, or speed also we can find it. See, if mu water is, we know that 4/3, mu glass is the 3/2, then velocity of light in vacuum, how much it is? You know that velocity of the light in vacuum is this is the permanent 3 into 10 to the power of 8 meters per second. Then how to find out the velocity of light in water? Look here, how we can find out not only water, for the oil and for the glass, whatever other material that other than air, you can find out the velocity of light in that particular medium. How to find out? With the help of this formula. What is that? This is the formula. So here, suppose the light is traveling from glass to water. So mu g W equals to, this is traveling from, this is the glass and this is the water, we can take it. So mu g W means velocity of glass with respect to water. Second medium is the water and first medium is the glass. So we can write it mu W by mu g equals to velocity of, both are inversely proportional, no? Here velocity in glass by velocity in water. If you want to take air also, you can take it. Here clearly we have taken, suppose in this problem instead of glass we are taking the air. Then here velocity in free space by and velocity in water. You know this value is 3 into 10 to the power of 8. Then velocity of the water we should find out. Velocity of light in water, not that velocity of water. So from this VW equals to how much? 3 into 10 to the power of 8 by, you know that refractive index of the water is how much? 4 by 3. After simplification, 9 into 10 to the power of 8 by 4. 4 2s are 8. 4 2s are 8. Then approximately you are getting 2.25 into 10 to the power of 8 meters per second. This is the velocity of light in water. So 9 by 4 is how much? 4 2s are 8. 2.4 2s are 8. 4 5s are, yes, 2.25 into 10 to the power of 8 meters per second. Like that, any medium you can find out the velocity of the light. Suppose we want to find out the velocity of light in glass. How to find out? Same formula we should use. Here we should write it. Take, that is, the light ray is falls on the glass plate. Here how many mediums are there? There are 2 mediums. Look here. See, light falls on the surface. Okay, this is the glass. This is the glass material, and this is the air. Then it is bending like this. Angle of incidence I and angle of refraction is R. In this case, you know that refractive index of the glass is 1.5. Refractive index of air is how much? 1. And the refractive velocity of the light in vacuum, you know that how much it is represented by C. That value is 3 into 10 to the power of 8 meters per second. Here velocity of light or speed of light in glass is how much? Same formula. You can take it, mu g by mu air equals to, inversely proportional means here glass came, means here velocity of air C by, here you are getting velocity of light in glass. After simplification, this value is 3 into 10 to the power of 8 divided by, this glass is how much? You know that 3 by 2. This 3 cancel when it will reverse. 2 into 10 to the power of 8 meters per second. So when we are observing in the case of water, what is the speed of the light? 2.25 meters per second. But here this is 2 into 10 to 2.25 into 10 to the power of 8, and here it is 2 into 10 to the power of 8 meters per second. But in space 3 into 10 to the power of 8 meters per second. From this what we are understanding? When the light travels from one medium to the another medium, based on the refractive index, we can observe the variation of the speed. Refractive index is less in air, but refractive index is more in glass. That's why speed is reducing. When you can go through the water also, that speed is little bit is variation and it is decreasing. So like that we should calculate the problems also. When we know the basic formulas, easily we should calculate this one. So anyway, this is about the refraction. This is about the refractive index. Then we can go through the, from the Snell's law also, how to find out the refractive index. Just now I said what is the Snell's law? It is the ratio of sine of the angle of incidence to the sine of the angle of refraction. When we are taking one example, when light falls on this, suppose this is the air and this is the glass we are taking, it is bending. Here this is the 30 degrees and we don't know about the R. We should find out. So how to find out? So just now I said this is the refractive index of glass with respect to air. Mu g by mu air. Mu g, you know that how much it is? 3 by 2 or 1.5, and this is the 1. Sine of the angle of incidence, how much? Sine 30 degrees. But we don't know about the sine of angle of refraction. Here we know the refractive indexes and we know the sine of the angle of incidence. We can find out the angle of refraction. How to find out? Look here, sine R equals to, sine 30 is 1 by 2. When it will come, it will becomes to 2 by 3. because this is the 3 by 2, 2 by 3, it is after simplification r equals to sine inverse of 1 by 3. This is the angle of refraction. This is the angle of refraction. Not only this one more topic we are going to discuss, that is the optical path. Optical path and geometric path. There are two paths are there, nothing is there. We are taking same time. See, if there is no medium, light is traveling like this. This is the optical path. We are taking this value is x. And how much time it is taking? T. Okay, this is the free space. Suppose you are taking, this is the medium. Then what happens? Same time. Suppose t equals to 10 seconds, 20 seconds, same time. But it can't able to travel that much distance. Why? Because of the refractive index. Same time, but it takes only d distance in the medium. So here you should use one formula, that is the x equals to nu times of the distance. How you are getting this one? Just now you know that refractive index, what is the formula? Velocity of light in space by velocity of light in medium. Okay, so here you can take, this is the formula for this one, and here x equals to distance equals to mu times of that d, means mu equals to one more formula we are getting, x by t. So not only in terms of velocity we can calculate the refractive index, in terms of this distance also, distance travelled by the light ray in free space by distance travelled by the wave in the medium, that is called the refractive index. We do one problem also based on this. Here, if x equals to 20 centimeters, then d equals to 4 centimeters. Can you find out the refractive index here? Easily you can find out. Mu equals to x by d. So 20 by, that is the 4. This is the 5. No unit for refractive index. Don't write here 5 centimeters. So there are many ways to find out the refractive index from the Snell's law, and from the velocity of light and in different mediums, and from the distance travelled by the light in different mediums also we can able to find out. Now we are going to discuss about what is the apparent depth and shift of the light. So here it's very interesting when we are going through towards the swimming pool, when we are looking that under the water floor is there. When we are looking in, that surface is nearer to us like that. When even you can jump in that, we can go far. Actually, the floor is like this, but when we are looking, it is like this. That type of distance, that type of concept is called the apparent shift or apparent depth. Also, we are explaining. See, apparent depth, very interesting. Apparent depth. Look, this is one surface. This is separating two mediums. One is the air, another one is the water, like this. Here two mediums are there. One is the air, another one is the water. You feel this is the swimming pool also. Actually, this is the floor. This is the floor. Okay, here soil is there and everything. This is the normal to the surface. Okay, actually what happens when we are looking through, your eye is here, there is no bending of the light, there is no refraction and there is no reflection. Straight you can see. Suppose you are here and you are observing this one. See, this is the normal. Then what happens? Really like this. This is the surface. Real depth is how much? X. Here real depth equals to x. But practically you should observe, whenever we are looking, see, this is the air and this is the water. Then what happens? Light is bending. Light is bending. Because of the bending, if there is no medium, it is having the straight line path. But here it is bending, and you can see this. The floor is here. Here y is called what? Y is the apparent depth. Y is the apparent depth. That is represented by y. And here how to, with the help of this also we can find out the refractive index from this Snell's law. You can say this is angle of incidence and angle of refraction. Our crash course, we are not going that much depth, just we are revising the formulas. Here apparent depth and real depth, with the help of this we can find out refractive index equals to x by y. So this is the refractive index. At the same time, apparent shift equals to that formula is x minus y. So instead of x we are taking x only, instead of y we are taking x by mu. Finally we should write this is 1 minus 1 by mu also. One more example is that there are different mediums. One is the water, another one is the oil, another one is the petrol, like that we are taking. When light falls on this, like this is the normal. When you are looking through these different mediums, in this case, how to find out the apparent depth equals to, just now you know that the formula is mu equals to x by y, but apparent depth is how much y. So here there are different, this one y equals to y1 plus y2 plus, like that you can take it, x by mu1. Otherwise this is the x1, here refractive index is the mu1, and this is the x2, this is the mu2 plus x2 by mu2 plus, and so on, x and by different, depends on the mediums mu and we are taking. When we are going through the apparent shift, how to write this one? This is the x1 into 1 minus 1 by mu1 plus x2 into 1 minus 1 by mu2 plus, and so on. So this is the, but the condition is, clearly you should observe that observer is in air, and we should observe the object is in denser medium. Any fish or any stone, any color stone. Just now I said that floor is here, like that. Instead of that you can take one color stone also. This is on the floor, but when we are looking through this, here we feel that the stone is here. This is called the apparent depth. But the apparent depth, there are two cases. In first case, the observer is in rarer medium, object is in denser medium. Like that, when you can go through the second case, all belongs to, you can observe that these are belongs to refraction only. These are belongs to refraction. See, in this case, observer in denser medium, object in rarer medium. Like that, always you know that fish is in water and this is normal to the surface. This is the fish is here. Here one color stone is there. So in this case, what we should observe, reverse of that one. Actually what happens, normal floor is here, the apparent depth is like this. But in this case, normal object is here, we feel that is here, like that. So here refractive index, we can say that, suppose the real depth is how much? X. Here apparent depth is how much? Y. Here refractive index, what we are taking? Y by x. It is the reverse of this one in all cases. This is about the apparent depth in different cases. Then we are going to discuss about, based on the refraction only, that stars are twinkling. Why? When the light is propagating because of the atmosphere and because of the different cases, refraction is changing, then we can observe that light is in different colors, like that. When we are taking one straw and we can keep in water also, it is bending like that. Okay, so all these cases are belongs to refraction. Now we are going to discuss about very interesting topic. What is the critical angle? What is the critical angle? This is represented by C. But in this case, light travels from denser to rarer medium. Light travels from denser to rarer medium. At that time what happens? Then angle of refraction is 90 degrees. Then only you can say that is the critical angle. Here light travels from denser to rarer medium. Particular angle, the angle of refraction is 90 degrees. That is called the critical angle. Look here. This is the denser medium. like water you can take it, and this is the rarer medium. This is like air. See, when light falls on this, just you put one light into the water, then light ray falls on the surface of two mediums. On the normal, you know that this is the angle of incidence. For particular angle of incidence, generally it is bending. When the light travels from denser medium to the rarer medium, what happens? It is bending away from the normal. So here you can say this is the angle of incidence and this is the angle of refraction. In second case, you see, this is the normal. Now the angle of incidence is I, but refraction is like this. Here refraction is how much? You can take I dash, this is the R dash, this is the 90 degrees. So here what do you say? I dash is the critical angle. Why? Particular angle of incidence. If the angle of refraction is 90 degrees, that is called the critical angle. Then how to find out how to give the relation between refractive index and critical angle? Here also we can use the Snell's law. What is that? It is a product of refractive index of denser medium. You are taking, this is mu2 into sine of the angle of incidence. Whenever it is equals to critical angle, instead of I dash we can take it C. Mu2 sine C equals to mu1 sine R. Okay, then mu2 by mu1 equals to sine R. R value we know that clearly 90 degrees by sine C. You know that sine 90 is the 1. It should be right. Mu2 1 is equals to 1 by sine C. If it is in air, mu1 value what we are taking 1. Finally, mu equals to 1 by sine C. From this C equals to sine inverse of 1 by mu. This is the relation between critical angle and this one. We do one problem based on this. Look here. If C equals to 30 degrees, critical angle is the 30 degrees. Find the refractive index. One more method to find out the refractive index. Just now you know that mu equals to 1 by sine C formula. C value 30 degrees. Sine 30 is 1 by 2. 1 by 2 is the 2. Refractive index is how much? 2. So if you know the critical angle, we can able to find out the refractive index. And we know the refractive index, we can find out the critical angle. Suppose for glass, how to find out the critical angle? Look here, sine C equals to sine inverse of 1 by mu. Glass, how much it is? 3 by 2. So C equals to sine inverse 2 by 3. This is the critical angle. So if you know any one parameter related to that, we can find out the refractive index or critical angle based on the given data. This is about the critical angle. Then we are going to discuss about the total internal reflection. What is the total internal reflection? When the light travels from denser medium to the rarer medium, same condition, but the difference is here angle of incidence is greater than critical angle. Then what happens? Light comes back into the same medium. It doesn't go to the other medium. That is called the total internal reflection. TIR. Total internal reflection. Look here, same. This is the normal to the surface and this is the surface and this is the denser medium and light falls on the surface. Here angle of incidence is greater than critical angle. For equals to C, it is grazing like this. Then what happens? Light comes back into the same medium. This is called the total internal reflection. Mostly this one we are using in the case of optical fiber to send the information without loss. We are using the optical fibers. Actually, this is the having two layers. One is the core, another one is the clad. Inside is the core and this is the clad. When light falls on the surface, first it is going like this, bending. Here one more normal. Here angle of incidence is greater than critical angle. Then it comes back. And here also angle of incidence is greater than critical angle, like this. And here also angle of incidence is greater than critical angle. Like that we can observe, see, through the pipe, it is like pipe, we are sending the information without any loss. This is called the optical fiber and it is based on the total internal reflection. Even diamonds also more bright, you can say that is also one of the reason due to the total internal reflection. So this is about the ray optics part 2, and this is one of the big chapter. One more part also is there for the crash course. Students, definitely it is useful for you. From the playlist after final exams, you can go through the day 1, day 2, day 3. So you can get both first year and second year concepts. This is the revision for MSET, NEET and mains exams. Compulsory, it is useful for you. And if you like this, you have to put like, and if you want to share to your friends, you can share. Definitely it is useful for others. And if you are subscribing my channel, I will make more videos. Definitely it is useful because it is belongs to the line. Thank you everyone. Please subscribe my channel.